Okay, it's recording.
All right, welcome everybody. This is a community meeting, August 15th, 2018. Starting with the agenda and notes, the first thing that might be noteworthy, Sebastian, if you would like to speak quickly about the Python client work you did.
Yes, so I just create a pull request about fixing the Python SDK. The problem is when we have an empty struct in our code, like the slurp interface and the bridge interface, that struct are not implemented in the Python SDK. So I created hard-coded files for that.
A hard-coded, I'm sorry?
Two hard-coded Python files with the empty class without anything.
Cool, thank you. And that ties right into the next agenda topic. As far as the Python client itself, we had an issue this week that came to my attention where the Python client was broken because of trying to marshal none objects, which is probably the same issue that you were just dealing with, Sebastian. In this case, there was a change to the Go RESTful Open API made by myself about a month and a half ago. That was part of the device plugin work, actually. We updated the deps, and that changed the way that we were creating the Swagger documentation, and that broke the Python client. So temporarily, we have reverted that that change to the Go RESTful Open API. It seemed to work just fine without it. So it was probably accidental on my part, just in terms of not realizing that that was going to have a harmful side effect we didn't realize. So the long-term fix, of course, is going to be we need to have the Python client be able to handle situations like this with nulls or nones in the JSON, which, by the way, is by default not allowed, but you can actually change that if we look into that. So then the next topic to discuss is IO threads. This is a PR created by me earlier this week, I think. There was some discussion about the correct default. I had assumed that 1 was the correct value, but there were some concerns with that. Vladik, are you here? He is. We'll give him a second to find the mute button if he's, there he is.
Yeah, in the window. Yeah, I'm just not sure about this because from what I understand and what I know, the what should be a value, well, the way it's supposed to be working is that we should have an ideal world, 1 IO thread per disk attached, and I'm not entirely sure where is the default, where is this saying that 1 IO thread suits all the workloads is the correct form. There are two main concerns here. Is that I don't know if we should enable IO threads if we don't have enough CPU cycles. This is one, and then the second one, I would vote for something more dynamic on behalf of the user. So we would just say that we want IO threads, and then we would calculate the amount of IO threads per disks. And of course, it has to be bound by the CPU, but we're already bounded by CPU in a container. So yeah, this is that's what I'm thinking.
Okay. Unrelated to that, I had a question in terms of the way we're doing it right now. I just sort of mimicked what KubeVirt itself was doing in terms of allowing the number of IO threads overall to be set and passing that through. It did occur to me that in theory it might be possible to look at or to add values to the disk structs themselves in terms of use IO threads and dedicated IO threads if needed. One would of course be dependent on the other, and just wondering if that also addresses the, the sort of auto calculation for, the user where they don't have to know the number or care. But it does introduce the possibility, one, that we can't translate it properly, that if we still have to go back to the way LibVirt's doing it, that we might, just because if LibVirt can only express the sheer number of IO threads, it might not be expressive enough to take something where we were trying to specifically talk about which disks needed IO threads. There might be a little bit of breakdown there. And also it fails on another point that I think you had made offline, Vladik, which is there's a concern about the max number of CPUs bounding. And if we just irresponsibly start assigning IO threads without account for the fact that you need one, maybe two per physical CPU, you might be getting yourself into some trouble there. So I didn't know what people thought of that, if that, in terms of, is that even possible?
Yeah, again, from my perspective, I like your approach that you just described. If we would have one setting, allow IO threads, and that's it, and we'll just calculate the right number, and we'll just start it for all disks, and that would be perfect, and take into account all the boundaries. And the other setting that you said about dedicated CPUs, I think this needs more discussion, because for me, dedicated CPUs, we could take out these IO threads when we have CPU pinning, and pin those threads into completely separated cores. So this is one. I mean, because there are two approaches to this. There one that says that if the container is already pinned to a number of CPUs, then we can just pin those CPUs, sorry, those IO threads, and we don't actually have to pin them. We can just let them float in the container, because container CPUs are already pinned. And then the other thing is that we could calculate the dedicated CPUs, where we would say that these IO threads need to be sitting on separated CPUs. Then we would just allocate more CPUs and pin them in the container, and then pin those IO threads to the additional CPUs. So I don't
know. I think it make things really complicated. I prefer to leave, like, I don't know, feature like IO threads possible, like open for user to set it, depend on his needed. Like, I don't know, if you want number of IO threads the same as disk, so just set the number of IO threads to number of the disk, and that's it. Because again, I believe it's very specific option, but I agree that we do not need to enable it by default. I believe we need to leave it disabled by default, but leave option to set number of IO threads that user wants, and it will, I believe it will be solved most of the problems. Because again, it's very specific to the configuration of the VMIs that user will have, and it's very hard to predict it and to calculate it.
I think it's pretty easy. I mean, like you're saying, yeah, this should be definitely disabled by default. But then you can express that you want IO threads, and you just calculate the amount of disks that you have, and see if it fits your CPUs, and if it doesn't break anything.
But before it, you said that it's not anytime it's good to use for each disk separate IO thread, because again, you cannot have, it can be a situation when you do not have separate CPU for each separate IO thread. In this case, it's like you do not do any increase of performance. So, and again, you also need to know other state of other VMs, what CPUs they used, and I don't know. It's like,
yeah, but this is in a container. Yeah, you would be right if this is a cloud, and then we have to care about others. But this is already in a container. We're already bounded by a certain amount of CPUs. So all we need to calculate if we have enough threads per CPUs, right?
So you want to check the C groups of the specific container and according to this information to set number of file threads, like.
Well, we actually have a little bit of work already in progress to that end, where in the vCPU patch that Vladik made in the last 8 days, I believe, he has some utility functions where he's actually checking the CPU sets inside the container, which I believe is the information we're going to need here. Or is it the vCPU sets of the host, Vladik?
It's in the container. But like all I'm saying is that, for example, the VM has four CPUs, okay, and we allocated these 4 CPUs in the VM, and now we're asking, but we have 10 disks, so 10 disks don't really fit, I mean, into 4 CPUs, right? Or say 20 disks. Let's exaggerate. So then there will be, if we take 20 IO threads for 4 CPUs, is it good or bad?
Well, so the question I have that's not clear to me is, are the IO threads inside the virtual machine? Are they part of are they visible at that level? Do they account for the number of CPUs inside the VM, or do they use the host level CPUs? Because the models I was seeing this seem to indicate the host.
It's host level CPU.
Host level, yeah. Inside the container, though.
Yeah, but again, for example, because you don't, like, you specified 4 core, but again, it's not say that Kubernetes will give you 4 core because it depended on request and on the limit.
Right, but what Vladik just said, I finally catch on and have the aha moment. The problem is the way we set up the virtual machines, we actually give the correct number of CPUs allocation to the pod, and then there happen to be the correct number for the VM. And so they are the same thing in this case, because you can only use the CPUs that are allocated to the pod or the container for the VM.
Inside the container, you see all CPUs. It's like, again, you will need to, you see all CPUs, but it's limited by C groups. For example, if you do not specify CPU manager an integer number of CPU, I believe it will be limited by quota or period. I'm not sure about how Kubernetes limit the container, but something like this. So you will need also to check this stuff. I don't know. Like,
no, I think not. I think you have it's in the limit. You have yeah, I need to double check that. Yeah, you may be right, but I think it's bounded by a certain amount of groups. Like it just.
So what's the difference, though, if it's limited by C group, whether we can see them all or not? We still can't schedule things on.
Just they will be floating on all the CPUs. It just depends on the amount of cycles that are allocated for this container. Yeah, Artem, I need to double check that. But this will definitely this will definitely work with pin CPUs.
Yeah, this for sure. So we can just separate two different cases.
So if I understand what you said, Vladik, we never need to worry about IO thread pinning. We'll just use CPU pinning and just specify the number of IO threads and let the IO threads float.
Yes, or we can over-allocate the number of CPUs with pinning. With pinning, I'm talking about only with pinning. We can over-allocate, and then if we need, we can put the IO threads on a separate CPUs if somebody needs that. But this is like additional feature. It's like a completely dedicated CPU, pin CPU for per IO thread. I don't know if this is needed.
Cool. Well, I captured the note anyway. That makes sense. So as far as the takeaways here, it's not clear to me what the next step is. in terms of what we should do? Are we coming up with a direction we should be taking IO threads at this point?
Yeah. I don't know. I know that for pinning, I would vote for what I said before, but Artur may have a point, and we need to double check if we have a host with 20 CPUs, will they all be visible in a container? If they are, then yeah, it's kind of it's more difficult to calculate, but need to double check that.
Okay, so that would be the action item on my part then, is to double check the visibility of the CPUs within the container and see if there's a way that we can strategically allocate them or over allocate the number of CPUs to the pod to not match the VM so that we can use them for IO threads. Is that what we're, okay, great. I can do that. And we seem to be pretty light on the agenda and notes topics for today. Is there anything anybody else would like to add as far as agenda items? Now's your chance. Okay, fair enough. And next we have the open floor. Is there anything that anybody would like to bring up just in general that aren't necessarily agenda items? I will take that as a no. All right, well, I guess that pretty much covers the what we need to discuss here. KubeCon will, I think it's September 18th is when they said, so if anybody did a submission, that's when we should hear back, assuming they're on time, which I've never seen actually happen, but they might be. So sometime late September, hopefully we'll know if and when we get any presence at the KubeCon North America in Seattle. And other than that, I guess thanks everybody. We'll meet next week.
Bye, guys.
Bye-bye.
Bye. Thanks.
See you guys.